Hello everyone, it's a pleasure being with you remotely today. It's a fact that we will not be able to meet our climate targets unless we rapidly scale a number of climate technologies. Of course, globally transitioning to renewable energy is the biggest part of the overall climate puzzle. Also increasing energy efficiency and energy savings. But the third most important category when it comes to meeting our climate goals is capturing and permanently storing carbon. And that's what Carbfix has been working on for the past 12 to 15 years or so. Here on this slide, you see Gullfoss, the golden waterfall of Iceland. It's the most powerful, one of the most powerful waterfalls in our country. The mass that you see flowing down the Gullfoss waterfall is equivalent to the amount of CO2 that we as a world jointly have to capture and store globally every second, every minute, every hour, every day, if we are to reach the goals of the Paris Agreement. So this is the scale that we have to build up the global emerging carbon capture and storage sector. If you're not familiar with the golden waterfall of Iceland, to put it into North American perspective, the volume flowing through Gullfoss is 1/25 of the volume flowing through the Niagara Falls. So quite amount of carbon that we have to start capturing and storing. And in Carbfix, our mission is to significantly contribute through climate recovery, through worldwide scaling of just that, carbon capture and storage. And what we do in Carbfix is that we turn captured CO2 into stone underground in less than 2 years through our proprietary technology that is imitating and accelerating natural processes. It's a fact that nature has for millions of years applied mineralization of carbon in the subsurface, in the rocks beneath our feet, to regulate the long-term CO2 concentration in the atmosphere. Because it's not just trees and vegetation that store carbon. Huge quantities are naturally stored in the rocks beneath our feet. In fact, over 99.98% of all carbon on Earth is stored in the rocks beneath our feet. It's only the remaining 0.02% that is found dissolved in the ocean, in the vegetation and soil, and of course too much of it in the atmosphere, as we are all aware of. So what we did in Carbfix was to figure out a way to speed up this natural process of mineralizing CO2 in the subsurface using science and innovation. So by applying our technology, CO2 can be transformed into stone in just 2 years, rather than the process taking hundreds to thousands of years, as it does in nature. The history of Carbfix dates back to 2007, when the International Carbfix R&D project was officially founded. And from the beginning, it was a partnership between research institutions and industry in Iceland, the US, and France. The world-renowned scientist Wally Broker was one of the founding members of Carbfix, and I was fortunate enough to have been part of the journey from day one. And at this point in time, in 2007, I was actually starting my PhD. This slide here shows a select few milestones that we have achieved since 2007. Of course, in 2007, we only started with an idea on paper on how we could, at some point in time, have developed a technology that would allow us to capture and mineralize CO2 in the subsurface. In the years that followed, we designed this equipment, so a lot of engineering involved, studying natural analogs, developing methods for monitoring and verifying that the CO2 would hopefully mineralize after we injected it. And in 2011, we did the first pilot injections with then our newly designed process and technology. Turned out that this worked very well. We ran a pilot phase from 2012 to 2013, and in 2014 already took the step to scale up to industrial scale operations and have ever since continuously captured and stored carbon from emissions of one of our geothermal power plants here in Iceland. So this year we are celebrating the 10-year anniversary of continuous capture and storage operations at an industrial scale. Continued to develop the methodology further, create new value chains, and in 2017, for the first time, we combined our method with direct air capture in collaboration with Swiss company Climeworks. So since 2017, we've also been able to permanently mineralize previously emitted CO2 through that joint process. Last year also hit a number of milestones. Want to mention a few of those here. We received the largest grant ever given to an Icelandic entity from the EU Innovation Fund for the Coda Terminal project, which is really the project we will take our technology to scale. A €115 million grant to build a value chain that allows us to link with our neighboring countries, capturing CO2 in one country, transporting it across borders to the location of the Coda terminal that will be here in southwest Iceland. And there we will build up mineralization capacity of up to 3 million tons per year for CO2. Last year also marked an important milestone in our continued R&D journey, because then for the first time we injected CO2 dissolved in seawater into the subsurface, which of course will be very important for the world, particularly the parts of the world where water access is scarce, because the way we do our injection and mineralization process is that we dissolve CO2 in water and now also seawater, and this is part of what speeds up the natural process so that we are able to mineralize CO2 permanently in just 2 years. So where we are now, 15 years or so after we started our journey, is that the CarbFix technology is thoroughly tested and proven by science. It offers considerable strengths and competitive advantages. It is permanent, it is 100% safe, it is cost effective, and last but not least, it is scalable. And now we've also reached the milestone of having it verified and certified by independent third parties. So how does the process work? We generally source CO2 through 3 different pathways, as I've already hinted to. On the one hand, point source capture and storage, where we have emissions of CO2 occurring in the vicinity of favorable storage formations. Where that is not the case, where capture is occurring at a larger distance away from favorable storage formations, we transport the captured CO2 with pipes or even ships across considerable distances, and then build up injection and mineralization infrastructure at a large scale at favorable locations, just as we are doing with the Coda terminal. And then thirdly, it is direct air capture and storage, and their direct air capture units are simply located where there is access to energy and access to favorable storage formation in near vicinity of one another. But independently of how we source the CO2, we always inject the CO2 in the same manner. And that we do by dissolving CO2 in water, and this can be using either groundwater from the storage reservoir itself, effluent water from nearby power production, industrial processes, and so forth, and now also seawater, as I mentioned. And the pieces of rock sample that you see here on the slide, these are cores that have been taken from some of our injection facilities and storage formations. The piece of rock in the middle of the slide, it's pure basalt, a young basalt. Basalts are one of the most common rock types on Earth. And you can see this young piece of basalt. It is very porous, had a lot of voids and space in it, and these can then be filled with mineralized CO2, and that is what is gradually happening by implementing our process. And on the picture to the right, you can see this basaltic piece of rock after CO2 has been injected into it using the CarbFix technology, and you see that the pores have filled up with new minerals, crystals, and these are carbonates that contain solidified CO2. So we've copied what nature already does, but we allow the process to happen that much faster by introducing our technology. And the only thing we need for the process to occur, it is a source of CO2, it is a source of water, and basaltic rock formations or similar geologic formations that are rich in cations, calcium, magnesium, and iron, that can link up with dissolved CO2 in the subsurface after injection. I mentioned that the method is scalable, and that is of course critical for all new climate technologies and solutions, because we have to be able to bring climate-friendly value chains to scale quickly. And basalts and other similar rock formations are one of the most common rock types on Earth. They cover about 5% of the continent and the majority of the ocean floor. And you can see here on the slide a part of our CarbFix Atlas, which is accessible on our website, that allows you to see where across the globe formations that are favorable for mineralizing CO2 can be found. And this is then showing where basalts are found. And the potential for applying CO2 mineral storage around the globe is enormous and far greater than will ever be needed for climate action. It's on the order of 250,000 gigatons of CO2 or so, and we need to take the technology cumulatively to a scale of around 100 gigatons up towards 2060, to put it into perspective. So the capacity is huge. We have a lot going on within CarbFix. We have taken the technology a long distance already. As I said, it's thoroughly tested and proven, and we have been continuously operating it at the commercial scale here in Iceland for 10 years now. But in addition to that, we have 4 field sites currently with ongoing operations. All of them are located in Iceland. We have 2 scale-up projects under construction, also here in Iceland. We have demonstrated injections already in 3 countries. In addition to Iceland, the technology has also been used for demonstrating CO2 injection in Turkey, and small volumes of CO2 have also been injected in Germany. We are developing commercial projects in 4 continents, including in Africa. We have secured 2 large-scale grants from the EU Innovation Fund. I've already mentioned the 115 million euro grant for the Coda Terminal project, which is the largest project we're currently working on. But then we also received a smaller grant for taking our technology to full-scale capture and injection of CO2 at the Hellisheiði power plant, where we began operations at an industrial scale 10 years ago. The way we go about introducing our technology to different parts of the world and new markets is through establishment of partnerships in target regions, because that way we are that much more successful in reaching scale efficiently. We're experts in introducing and applying our technology in favorable geologic formations. We are not the experts in the different in and outs of getting permits for these types of projects in the different jurisdictions across the globe. So we work a lot with partnerships. We also continue to put great focus on taking the technology further through continued R&D. With the objective of increasing the efficiency of the technology by demonstrating further that we can use seawater, and also by testing mineralization of CO2 in different geologies. Of course, how we act and invest now and in the very next few years on our planet is going to profoundly affect life on Earth for the next few thousand years. And in the Arctic, where we are located, we are already experiencing the impact of a hotter planet. The Ok Glacier was the first Icelandic glacier to lose its status as an official glacier. And the photos on the slide, they are from the glacier's funeral, which was held in August 2019, when CO2 levels in the atmosphere were around 415 ppm. Now they're higher than 420 ppm. So where Ok used to be, we now have a monument comprised of a letter to the future that says, Ok is the first Icelandic glacier to lose its status as a glacier. In the next 200 years, all our glaciers are expected to follow the same path. This monument is to acknowledge that we know what is happening and what needs to be done. And only you, the future, know if we did it. And Carbfix is stepping up to the challenge. We are ready to do our part in really addressing climate change, of course, through partnership with others. Thank you.